Alright, hello and welcome to a new week. We were talking about arrays last time, and we will continue with those today, do some fancier things, and then get into these things called vectors, which are like much cooler versions of arrays. So we ended here with undefined behavior, talking about how it is a very bad idea to try to access past the end of an array, because maybe your program has access to that memory, but it's not holding anything that you want it or think that it is holding, okay? So it might be something very special, and it might ruin your program if you mess with it. So let's have a quick recap of arrays up until this point. So arrays, they hold a bunch of stuff of a certain type. For example, I've been showing you a lot of integer arrays, but we can have double arrays, char arrays, and we'll talk about those later. And so on and so forth until the end of time for every type that we know. An array of strings, for example. So that you have to pick the type, and that is that. And also, they have a certain size. And it's whatever you give it. You have to say what the size is. And it can't change later. Okay? And just like strings, you can index into those arrays. And get or set the value there. So if I say int arr bracket bracket equals, well, that was a horrible brace. Don't mind me. 1, 2, 3. Well, then in memory, I have my array. It has space for exactly 3 integers, and I can change them to other things, but right now I've made them 1, 2, and 3. Okay, so this array 0 is the 1. Remember, this is index 0, this is index 1, this is index 2, and we can change them. Not a problem. But there is not index 3 or greater. Those don't exist. Don't try and access those. We only had 3 elements, and we could have put a 3 there just to drive the point home. Okay, so that is a quick recap of arrays, and we can fill them up with stuff from the user. And that's fun. So let's do more. We've made our arrays so far to be singly dimensional, I guess. So we have like 5 things. That's one axis. We can have many axes. We can have as many as we want, actually. The most common thing to do is to have a 2-dimensional array. So here is an example of a 3 by 3 array. And so this is how you would declare it, int arr with the sizes. So you'd say int arr 3 and then 3. And this is kind of a hint to show how to use it as well. You have to use 2 sets of brackets. Okay? This is exciting. Yeah. I just want a semicolon, please. So, whichever way you want to think about it, doesn't really matter, but you have your first index and your second index, and let's just pretend that the row is the first index. 0, 1, and 2. 0, 1, and 2. So this is first index. This is second index. So if I wanted to access this element right here, that would be index 2, 1. arr 2, 1. You see that? And I can set that and print it. So for example, when would you ever want to do this? Well, images are 2-dimensional. Like this one right here. It's just got a bunch of tiny little rows of pixels and a bunch of little columns of them as well. And so if you want a given pixel and you want to know the color, you have to go and index into that. Okay? It is a 2-dimensional array deep down. That's all an image is. So it holds like at index 0, 0, 0, 1, 0, 2, different colors. And that's exciting. We might get into pixels and like image processing later in this class when we talk about Python, perhaps. But yeah, just an array with multiple indices, and you can just have as many as you want. You could say int ARR 3, 4, 7, 9, and so on. And you can just have a 4-dimensional array if you wanted. Okay, that one's hard to draw, of course. But if you say it like this, just like up here, you have the following accessible indices. Okay, you can say ARR. I'm going with this example now. You can say ARR 0, 0 always. And you can go up to ARR 0, not 84, but 83. It's always one less, of course. Always one less. 83, and then so on and so forth until ARR 4183. Okay? And just like loops, they multiply, so you have 42 times 84 accessible elements. And isn't that cool? Alright, so let's just have a quick example of multidimensional arrays. CSCI 40, we're on lecture 9. Oh, not 90. There we go. And let's make a file called multidimensional. I think I spelled it right. Okay, so let us make an array of things, and I don't know what we'll set them to, but we'll figure it out. Let's see here. Let's make an array of... No, ints are probably the easiest still. So we'll call it multi. It'll have, I don't know, be a 4x4 element, multi-dimensional array, and this is an uninitialized multi-dimensional array. So right now, just like anything else, just like a normal array, everything's got question marks inside. What you could do is the following. Init. You could do the following. You could say int multi init 3 equals, and then you can give arrays of arrays, because what is a multi-dimensional array but a bunch of arrays of arrays? You can give 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah? Isn't that fun? So it's like you put little arrays inside of your arrays, and so this is a 3x3 initialized array. And I know what's going to happen with this comment, so I'm just going to fix it now. Okay, that is the idea. And let's go and iterate through this multi-dimensional array and print out all the elements in a nice way. So this is a job for a nested loop, because I can have 1, 2, 3, 4, 5, 6, 7, 8, 9. I can have I keep track of the first index and J keep track of the second index. Oh man, isn't that beautiful? So what is this range between? The highest index for both dimensions is 3. I++. And 4 int j equals 0, j is less than 3, j++. So now when I'm inside of here, I have an ij pair. That I can use to index into the multidimensional array. Alright, so let's just go and print everything out. Cout multi init I j, and these will all be on the same line. How about that? And then after I'm done with a inner array, I'll print out a new line. Okay, so this is kind of hard to think about, so let's just watch it run, and then it should make sense. Boop. All right, so isn't that fun? We can fill up arrays with what we want to display, and we can even print it out just like it was in a box. So pretend that these were colors, and we just printed a beautiful picture for ourselves. Okay, so that's a multi-dimensional array. Sometimes it makes sense to think about data in a multi-dimensional way, like an image, and it's very easy to make a multi-dimensional array that can give you access to that ability. To talk about index 1 and index 2, what's there? Yeah? Okay, that's multi-dimensional arrays. I've told you about vectors. I've kind of built them up in your mind quite a bit. What's so good about them? Well, to get to that, we need to talk about the bad things about arrays. So one of the bad things is we have to say the size of that array up front, and it can never change, remember? Okay? Like there's no fourth element. That's a problem. We don't know what size the array is in general unless we save that somewhere or remember it ourselves. And in all my examples so far, it's just been a constant. So that's no fun. Well, you kind of have to save the size somewhere or just remember it. Okay? The array itself, you can't go into the array and say like ARR, hey, tell me your size. No, it doesn't work. So the array itself doesn't know its size. So that's no fun. It should remember for you. And then also you can accidentally go past the end of it and not know any better. You might get a weird value, you might get a normal looking value, you might even be able to set it and not have your program complain. But that is unfortunate. Okay? Let me show you the program complaining when you do access past the end of an array. I'll just put it right here very quickly. Int ARR 42, and let's try and see out ARR 4096. It's gonna warn me. It's like, oh, past the end of the array. Are you sure? Are you sure, bro? I'm sure. And we get this thing called a segmentation fault, which is a runtime error, okay? We try to access memory that was not ours. That's no fun. But instead of having an array like this and being like, hey, what's your size? I don't know. And trying to access the element way over here and get a runtime error and not be able to tell, we can use this thing called a vector, and it will solve all of these problems for us. Okay, so vectors are beautiful, and we should always use them when we can. Okay? Yay for vectors. But before we get there, let me show you how to swap two indices in an array, because this will be helpful later. Okay? So this is pretend that we have an array that looks like this, and maybe we wanted to reverse it. That means these two bad boys need to swap places. We need to bring the 3 here and the 1 here. How does one do that is the question, and let me show you. Okay, so here is array 0, 1, and 2, and, well, we would like to bring index 2 into index 0, index 0 into index 2. Let me show you. There's a bit of a subtle issue, and I think I just accidentally clicked that, but that we will deal with in a second. feel free to use VS Code as well. It's quite fun. There we go. Okay, so I'm going to make a program just called swap indices. So here's my array. And I want to swap indices 0 and 2, so the 1 with the 3, okay? Now, how am I going to do that? I don't know, so let's just pretend that we did it, and then print out the array at the end. Okay, so right now it's just going to print it's just going to print 1, 2, 3 because we didn't do anything. But now let's try and swap the indices 0 and 2. Is it as simple as, hey, is array 0 become array 2? Hey, oops, forgot a semicolon. Hey, array 2 become array 0? Is it as simple as that? It is not. So this was unfortunate. We lost the 1, remember? So in this line, we brought the 3 into index 0. We did this. Let me write it down here. By doing array 0 equals array 2, we did this right here. Boop, boop. Yeah? And so then we just lost the 1 that we were going to put right here. Oh no. Oh no. Well, what can we do? We can save that 1 before we mess with it. Okay, so how about int temp? It's a temporary variable that will store that value before we need it. Int temp equals array 0. Save it for a second. Alright, because then I'll have a temp over here that holds my 1, and then I can put temp inside of array 2. Okay? And I can say array 2 equals temp. That will work. You need to save the 0th element before you replace it, because otherwise you'll just lose it. Okay, so I hope you see why it works, and this is a very common thing. Oh, what have I done wrong at the moment? Oh, I didn't change it back to temp. I hope it makes sense. 3, 2, 1 now, so we swapped the index 0 with the index 1, and everything is golden. How do you remember which goes where? Like, was this 2 or 0? Was this 2 or 0? Was this 2 or 0? Here's a pattern that I don't think anybody told me, but I saw it when I was learning this thing. It's always right here. This matches up with the left side. The right-hand side of the first line matches up with the left-hand side of the first line. There's like a correspondence. And then it just continues that way. The right-hand side of this line matches up with the left-hand side of this line. And then finally, they kind of wrap around. You got this temp, this temp matching up with this temp. If that made any sense to you, you can use that pattern. But otherwise, just write these 2 lines, figure out what went wrong, and then use the temp variable appropriately. Okay, so that is swapping 2 indices in an array, and that will be super helpful for an example that I'm going to show later. And so with that, we now get to do cool stuff with this thing called vectors that I've been hyping up for you. So hopefully it all works out. If you go and look at the documentation, and I do encourage that, you can see what a vector can do. So here it is, and you can get cool stuff from a vector. It's very similar to a string, so let me say that. I probably need blue. In the sense that you could do dot stuff on it. Okay, so you can get its size. It remembers its size. Oh, beautiful, beautiful. You can use the array-like brackets, but I would prefer you to use this at function that I will show you how to use, and we'll talk about the constructor in a second. But gosh, is vector a wonderful thing, and it's so beautiful. So let's do this. A vector is called a dynamic array. That is the technical term for what it is. And because of that, dynamic means like it's moving, it's running, you know. That means that its size can grow. You can add stuff to it. You can add stuff to the end with the pushback function, for example. Okay? Let me write that. And if you try and access a weird element using the at function, you'll get a runtime error. So you can say, if you had a vector and you were like, hey, give me v.at 4096, and see out that or something, well then you get a runtime error, because this would be like, or you get a different kind of error that you can check for, actually. You get what's called an exception that we'll talk about later in this class. But this is much better because it says exactly what went wrong. It's like, oh, that was not within your size, dude. Try again. And it's so nice. It knows its size with the dot size function. And you can also set an initial size and initial elements just as normal. So let me show you vectors. Dun, dun, dun. The first one, very simple. Let me show you 2 ways to make a vector. Hold 1, 2, 3. Okay? Vectors.cbp. So this is a library, so you got to include it. Got to include vector. Okay. So now instead of saying int arr dot dot dot, you'll say vector of ints with these little less thans and greater than signs. I want a vector of ints, please, and I want to call it v. Okay? And I want that equal to 1, 2, 3 as normal. Okay? So let me read this to you. This is saying v is C++. Please make space for a vector called v that holds ints. Okay? That's how you read it. It's a vector called v of ints. It's a vector of ints. Okay? And this weird syntax is just something that you will get used to. Alright, so it's a vector of ints. We're calling it v, and we're setting it equal to 1, 2, 3. Okay? So that's one way to make it 1, 2, 3. And we can do everything as we did before. For int I equals 0, I is less than 3, I plus plus. Undo. Oh no, don't undo that far. I plus plus. We can do cout v bracket I new line, but this is silly. We don't like this. This is array style stuff, and it's error prone. We don't like the following. It's error prone. So here's how you fix it. The above is equivalent to this. Alright, so we can say for int I equals 0, I is less than 3, that's a hard-coded number. This vector knows its size. Get it. v.size. I plus plus. Oh, isn't that beautiful? Isn't that beautiful? And then we can say cout v.at I new line. Okay? That is equivalent, and this is the cool way to do it. All right? It's the way the cool kids do it right here. It does the same thing. It knows its size. We use the at function because it's safer. All right? v.size gives back, returns the size of the vector of v. v.at I is a safer, it's a much safer way of doing safter. v of I. Oh man, things are looking up. And just to prove it to you, like here, let's see out the size. And let me show you how cool the at function is also. Are you ready? Out of range. Yes. You're trying to get 4096, but the size is 3. Isn't that the most helpful error that you have ever seen? This is essentially useless. This is glorious. All right, so always use the at function, always use vectors as much as you can. All right, so that's one way to make 1, 2, 3. Let's do it another way. So vectors can grow in size with, for example, the pushback function. It's really called a method, but we're going to conflate those at the moment. So, and you can always go to this page and click on something to find more about it. Pushback. Dun dun dun. And say vector.pushback and what you want to give to the end. It's so beautiful, and it'll make it the new last element. Okay, add it to the end of the vector after its current last element. And it can grow as big as you want it to grow. Okay? Oh, it's so glorious. This is a wonderful thing. I'm excited for you. All right, so we can say vector of ints v2 semicolon. This vector is initially empty. Okay? This is an empty vector right now. There's nothing there. The size is 0. We can say v2 size. It's currently 0. We can add stuff to it though. We can say v2.pushback 1. So it adds it to the end. Now the vector holds 1. And you better believe that its size is now 1. Oh yes. And so you can just watch it grow here. 2, 3. Oops. That was not the number that I wanted to increment. There we go. So now you can watch it grow one at a time. Its size is now 3 after this pushback. And we can go and print it out just like we did this one. That's v2's size. So they're different vectors. They just happen to have the same length at the moment. v2 at I. We did it. So we made one vector, just, hey, take all my stuff. You can actually add to the end of this, of course, with pushback. You just gave it initial values. And then this one we built up from scratch, from 0. Size 0. And we got to the same place. Okay? That's 2 ways to do it. Alright. And so you can use that pattern to get as many elements as you want from the user. But before that, I want to show you how to set an initial size and initial elements as well. Okay, so that's a fancy thing called a constructor. That's its job. There's different ways to make a vector, if that makes sense. And so we've used a few of them. We used this one. You don't have to understand this, don't worry. We used this one to make it full of stuff. We gave it what's called an initializer list. And then this one, we just gave it nothing, and so that's like the default the default constructor that makes it blank. But don't worry. What you can do, though, is use this thing called a fill constructor. We can say, hey, I want my vector to have a certain size at the beginning, and it's probably easier to read this and actually look at the examples. We can make a vector of size 4, and all those 4 things are 100. So 4 ints with value 100. I really encourage you to click these things and then scroll down to the examples. Those will save your life. Okay, so here's how you use that. You can say, I want a vector of 4 things initially, and I want them to all have 100 in them. You can leave off the comma 100 if you wanted. It would just be initially having 4 things of random values. All right, so here's how we do it. How do I want to say this? So vector int, let's make a vector of doubles. Vector of doubles v3, and then we'll say, I want it to hold 314 3.14s. Yeah? Following this pattern. 4 100s, those are ints. I want it to be 314 pies. Alright, so now you can see out the size of E3. It'll be initially 314, and then you can go to any index into V3, and it'll be 3.14. Isn't that fun? So this is a vector of size 314, holding nothing but 3.14s. Isn't that fun? Oops. Always does that. All right. So I hope you see the power of vectors. Gosh, they're beautiful. And all right, so now let me show you how to get infinity elements from the user until they type -1, for example. And anything that we don't know ahead of time how big it's going to be, how many things the user is going to type for us, that should scream loop to you. Okay? We're going to have to keep doing something until they type -1. Okay? So now, going down here, let's get as many ints from the user as they want to type. -1 will signal the end. Okay, so here's how we'll do it. We'll make a vector of ints. I don't know what should we call it? User's input, semicolon. So it's initially empty. And then what we can do is just get stuff from the user. We can say int current input. Now we can get that from the user somehow. And we're going to have to ask the user, of course, to enter something. Got to be nice. Please enter the next value. Something like that. And then while the current input is not equal to -1, we put it inside of the vector. And then also ask for the next value. Okay, hopefully that makes sense. We'll ask the user, hey, enter some number. We'll make space for it and get it. And then we'll keep on doing that. We'll keep on putting it inside of the vector itself and asking for the next value. So at the very end, after we code this, we'll have a big vector full of stuff. So we'll say user's input dot push back whatever the current input was, and then we'll ask for the next value, doing all this all over again. So a slightly cleaner way to do this, is there's a way to just have this in the body. You can start out current input with a special value, and then you wouldn't have to repeat it up here. but I like it this way. There's no problem. You could even use this thing called a do-while loop, which you might read about in your book. But this is looking good to me. So here's what we're doing. We're making a vector, user's input, that is initially empty. There's nothing there. And then every time we ask the user, hey, enter something, they're like 42, 43, 44, and then they're like -1, and each time they enter something, we add it to that vector. Okay? It's like, we change it to be, it's no longer empty. It has just 42. It has now 43 at the end of that. It has 44. And then once we hit the -1, we stop. And this is our final vector. Okay? So now, after the end of this loop, once we get here, the user must have typed -1. And so we're done. Let's print out what they typed. So we can say, you entered, and then just start giving the entire array. So for int I equals 0, I is less than current, sorry, not current, user's input dot size, I plus plus, cout user's input at I, and then a space. We'll keep them all on the same line, and then a new line maybe at the very end. All right, so are you ready? Please enter the next value. So we're here. Boop. We can't enter -1 and just not have anything. Let's try that. You entered nothing. So it loops through an empty array. It doesn't even do this body at all because the size is 0 and 0 is not less than 0. All right, let's enter stuff now. Let's be like 1. Ooh, enter the next value because it wasn't -1. We're back here. We pushed the 1, and now we're waiting to get another value. 2, 3, 4, 5, 6, 7, 8. Oh, oops. It'll still work. 9, 10, and then -1. Oh no, what have we done? -1, -1, -1. What is wrong with this? Let's see here. I don't immediately see my bug, so I'm going to go and look at this code and come right back. I see what I did. I made a brand new current input variable, and I shadowed this one. Shame on me. That'll fix it. 1, 2, 3, 4, 5, -1. 1, 2, 3, 4, 5. So my error was making a new current input variable. There should only be one that we keep checking against -1. I was shadowing it in here. That was my mistake. All right. So that is that. Entered 1, 2, 3, 4, 5, and we can go on forever until the end of time for as much memory as our computer has. We can ask the user. So this vector is not constrained on size. We don't have to be like, it holds 42 things, no more, no less. That's what vectors give us. It's beautiful. All right. So we have been iterating through vectors the old array-looking way still. We've been using that for int I equals 0, I is less than v.size, I plus plus. That's still an array-looking way. There is a fancier way that was introduced in C++ 11. So if you're ever wondering why we're doing standard equals C++ 17, it's for reasons like this that I'm about to show you that will make your life so much easier. So instead of all of this, vectors, for vectors, not arrays, you can have a fancier kind of for loop. You can say for, and then it'll go through in here each individual element and pick it out. You can say for int elem, for example, in, read the colon as in v. cout elem. Now this is the coolest thing, because this all gets replaced. That's hard to do. We didn't even need the I, we just needed the actual element. Each element will be picked out, each single element of the vector. There's 1, 2, 3. It will, for you, make element in the first iteration 1. Then it will make it 2. And then it will make it 3 in the third iteration of this loop. It will do that for you. So let me draw that in a different color maybe. Elem gets set to the current element of the vector. And it's advanced for you. Advances elem each time. For you. Isn't that cool? So, let me show you this in action. And this is called a range-based for loop, by the way. I'll give it that name. So vector int v equals 1, 2, 3, 4, 5. So include vector. So instead of for int I equals 0, I is less than v dot size, I++, we can do, assuming all we wanted to do was actually get the elements, was unnecessary and just helping us get the elements. We can do for int, it's the type of the thing that's inside the vector, elem in v. Okay, that's what we can do. So for int elem in v, we read the colon as in, then just pretend elem is the next element each time. So it's like indexing for you. You can cout elem. Elem changes each loop body iteration. Okay? One, two, three, four, 5. Isn't that beautiful? So here, in essence, what's happening is here's elem. In the first iteration of this loop's body, elem is set to the first element, 1. And then for you, C++ takes care of it. The next time it comes back to the body, it'll be 2. Elem will be 2, and then we can print that out. And then the next time it'll iterate for you, it'll make it 3, and then it'll make sure that it stops there because there's nothing left in the vector. So it's like it knows how big the vector is because it stores its size. It's doing some secret sauce, but this is going to be helpful, I think. So this is how you can iterate through a vector. This does not work for arrays. Okay, there's a C++ 11 and later type called array, and that will work, but the basic type that I showed you up here with the brackets called array, that is not going to work for that range-based for loop. Okay, so another reason why you should use normal vectors all the time. Okay, no arrays. Alright, there's a way to sort arrays, and you might find that useful one day, so let me just show you that. It's in the algorithm header. So it's in, I think it's other algorithm. There's plenty of nice things that you should look at and maybe use one day, but there is sorting. there's a sort function. And so here it shows an example for vectors. You can say sort begin and end. Okay? So let me show you that very quickly. Maybe I'll make this 5, 4, 3, 2, 1. 3 is the same. How about that? Let's sort the vector using standard sort. And obviously we included namespace standard, so we didn't have to use that part anymore. So it's an algorithm for sort. So you say sort v.begin, comma, v.end. Okay, that's how you do it for vectors. This also works for arrays. You can use this as well. It's a bit beyond the scope of the class at the moment for me to explain what begin and end means, but it's telling the sort function where the end of the vector is. It's like 1, 2, 3. You can think of begins as like pointing there, somehow points to there, and v.end somehow points to something after the array that doesn't exist, or something after the vector that doesn't exist. So feel free to come to office hours and I will explain this to you, but it is beyond the scope right now. I just wanted to show you the sort function because you might need it. And this is how you use it. And then we can go and print out our nice and sorted array now. So this actually updates the array. It's not like this gives back a new vector or something. Sort just updates the array itself and messes with it. And what do you know? My 5, 4, 3, 2, 1 is now 1, 2, 3, 4, 5. Isn't that beautiful? Maybe it would have done better to have a new line in between the two, but you get the idea. That beautiful sort function. Okay. Now finally, you knew we were coming here. Reversing the contents of a vector, or an array, for that matter. Let us do this. This is our difficult example, our hard algorithm. Okay? Let's see how much time we have to do this. This might be something that I introduce right now, and then next lecture we will come back and implement the thing. Okay, so let's get the idea down for now. So I have a vector. Let's pretend it looks like this: 1, 2, 3, 4. And I want it to somehow be transformed into 4, 3, 2, 1. So maybe pause the video, think about what needs to change in this vector. Where do things need to go? So maybe, if you stared at it long enough, you noticed the following pattern. Those need to swap, and those need to swap. Ooh, we know how to swap things. Okay, what if I had v2? Because this is different in each case. 1, 2, 3, 4, 5. And I wanted to turn that into 5, 4, 3, 2, 1. Notice the difference. Yes, those need to swap. Yes, those need to swap. This one, I guess we could swap it with itself, but it's kind of useless. Notice that when it's an odd numbered array, it's a bit different than an even numbered array. Okay? You see that? So, we just need to swap indices. We need to swap 0 with the last one, the next one with the 2 previous. So it's from the second to last. So like the 0th element with the 1, 2, 3 with the 4th element, and the 1th element with the 3rd element, things like that. Because this is technically the first, and I'm going to call it the 0th. All right. So, well, how do we do this? How in the world do we do this? Well, let's break it down. we need to swap indices. We just noticed that. Which indices? We need to swap 0 with, in this case, 3, and 1 with 2. 0 is fine. We can make a variable called, starting at 0, for example. We can have it be called I. How do we get 3? How do we get 2 in the next iteration? So we can just keep on adding 1 to I, and that'll work out. Well, this index is always going to be, no matter the iteration, like for this one, we want to swap 0 and 4, 1 and 3, 2 and 2 even, if we wanted to. We could stop before this though, of course. Well, if this is I, this is always, think about it in terms of the vector and I. How can we get there? Well, it's the size. This is 5 minus 1 for this one, 4. When I is this is the size minus 1 minus 1. That works. When that's I, this is the size minus 1 minus I. So it's always minus 1 minus I. You see that? And that works over here too. If this is I, this is size minus 1 minus I. And so on and so forth, as we increment I to be 1, to be 2. Okay. Then, we need to know when to stop. We gotta swap these, that's one iteration. We gotta swap these, that's another iteration. And we can swap this one for fun, that's a third iteration. How do we turn? How do we always know to do it 3 times for this one, and 2 times for this one? Alright, how many times do we iterate? I and size minus 1 minus I, and that's a 1 right there. How do we know when we're done? How do we know that we only need to do 2 times here? How do we know that we need to do 3 times here? Really, we could make it 2 again. Well, again, it's always in terms of the size. It's kind of like we got to swap for half the array. You see that? It's 2 swaps. It's kind of, you mirrored the array at that point. Well, this is size, 4 divided by 2. That works. We need 2 swaps there. This is size divided by 2. 5 divided by 2. That also equals 2. We can get away with 2 swaps here. Ooh, that might work. What if we swap size divided by 2 times? Yeah? Would that work? Okay. I think that's where I want to leave us on that note, and we will come back and implement this together.